Hello, my name is Jeff Passmore. I work for JDSU's Sales Support Organization. I will be your host today in an introductory video for our newest ultra far end device called the UFED IIB, B standing for Bonded Service Pair Testing. The original UFED JDSU was first to market with a far end device capable of testing through the VDSL2 spectrum of 30 megahertz. We are equally proud to be first to market with a far end device that includes the critical measurements for bonded service pair testing of next or near end crosstalk and fixed far end crosstalk. As a telephone man myself, I look back on, of course, quite a while ago, but we didn't have far end devices, but we certainly all had locate toners. Well, it dawned on me that when I used the locate toner, I was actually in a double-ended test mode, right? Because I had to hook that toner up somewhere and then run somewhere else to find the tone. So really, I was in a double-ended test mode, but the only thing the device could do for me was send tone. All right? Well, if you think about the UFED that way, it makes all sorts of sense because we can certainly send tone, but we also do a whole bunch of other stuff. So it's sort of like having a helper on the other end of the loop. And instead of slowing the process down, we at JDSU actually think it will speed the process up. It will certainly lead to better and more accurate testing. A fellow that taught me a lot about troubleshooting in the field always used to say, Jeff, if you can control both ends of the circuit, there's pretty much nothing you can't identify and repair. It only becomes difficult when you can only control one end. Well, with a far end device, you are controlling both ends of the circuit. So let's start by looking at the unit physically. If you have not seen one or you don't have one sitting in front of you, it's a hard plastic device, a little bit bigger than a pack of cigarettes. I'm showing you the opening face here. Comes with a nylon carrying case and, of course, a set of test leads. First, we'll discuss the opening face here, or the label. The red button is the power button. Directly above the power button is an LED. A little LED will flash in accordance to the flash pattern diagram here. Different cadences or flash patterns for different functions. And it's really nothing complicated at all. If it's in a command mode, it will have a rather quick series of green flashes, as opposed to the trace tone being on. It's rather a slow blink, right? And finally, if the battery goes low, the green LED will actually turn red and flash as an indication of, hey, the battery's getting weak. The UFED comes with 3 sets of tip and ring leads. The yellow set I call the CO side or F1 side, however you'd like to think about it. Of course, it has a ground lead, the green lead, and two field leads. Primary field lead number 1 being labeled blue, and primary field lead number 2 being labeled with red. The whole device is powered by a 9-volt battery, which fits inside the back of the unit. Here's a picture of the cords themselves. They attach to the far end device via an RJ45. And here you get a good look at what the coloring looks like on the cords. So my yellow marked leads, COF1, however you want to refer to them, there on the left. Green is ground at the top there. And primary field lead blue, number 1, and primary field lead 2, red, number 2. We said the purpose of this introductory video was to go over some of the just basic operations, but also to tell you a couple of do's and don'ts. You may be under the impression, depending on what you've heard about the far end device, that, well, yeah, it's for U-verse pair testing only. Well, we certainly hope, while that's very important, obviously, to AT&T, we certainly hope you get more out of the far end device than just testing U-verse service. In fact, you can use the far end device to test anything from POTS, ADSL to U-verse. So As you use it in your day-to-day functions more and more, you probably find yourself in a single pair mode. What I mean by that is you'll probably just hook up your blue leads to the pair that you're testing, green to ground, go find the pair and talk to it with the HST, right? Meaning that the red and the yellow leads were not being used. In that case, one of the gotchas or one of the things to look out for is to make sure that the unused leads are not shorted together. Now, there's a real important reason for that. The red leads shorted together, for example, disrupts the communication circuit for the far end device. And HST has a very hard time talking to it if the communication path is disrupted. In the case of the yellow leads, there is a particular command mode labeled off through. Now, what off through does is pass whatever is hooked to the yellow leads straight through to the blue leads. Now, the purpose of that, obviously, is to restore DSL or restore dial tone from a remote location without having to drive back to the customer or the crossbox, depending on how you're approaching it, right? So if you inadvertently shorted those yellow leads and gave it an off through command, you would pass a short circuit right through the device to the blue set of leads. So it's pretty important if you're not using them to have them clipped so they're not touching one another. And this is exactly, it's a picture of my device actually. It's how I store the leads when it's not in use. Well, what's new? Well, the UFED, as I said, has been around for a while. The main thing from a technology standpoint is the introduction of the next and fexed measurement. Well, we'll talk about that later with our more detailed discussions or videos on the script itself. The thing of interest, especially if you had one of the previous UFEDs, is this next feature. It's the ability to wake the Fed up or knock it out of a command state. Our first release of the UFED, you sort of had to set your mode there with option number 1, right? You give it a command, select the pair that you wanted to institute that command on, pair 1 or pair 2, and then you had to set a duration or a time period for how long you wanted that command state to remain on the line. Well, if you made a mistake or you wildly underestimated just how long 120 seconds is, quite often you were frustrated because the UFED was dead to the world until the timer expired. Well, based on a lot of technician feedback, we in our newer model have found a way around that, so we can abort command states. So if you do make a mistake or you realized that you really only needed 30 seconds instead of 120, you can simply hit the wake up button inside the manual Fed commands, or we'll show you in the integrated Fed commands under the Actions tab, just simply give it a new command. That will automatically abort the current command and turn its ear on listening for the next command. You can think of using the Far End device in 3 modes, 3 different modes of operation. Certainly with the AT&T scripts, and that mode is completely automatic. The only thing you have to do is make sure that you're connected to the right cable pairs, right? Push the button and all the communication between the Far End device and the UFED is done automatically. The second mode, which I think we'll give you an example of in today's short video, is underneath the Actions tab. So the Fed commands are actually integrated into the particular tests themselves. The one I'm showing you here now is TDR manual mode, where you can see option number 8 is listed as Fed commands, and 3 primary commands there are available under the TDR. One being TDR helper, the other being open all, which simply means, hey, disconnect the Far End device entirely. I want it off the line. And then number 3 being, hey, short tip and ring for me. And then finally, the much more manual intensive way of interacting with the Far End device. It has its own manual Fed menu. It's usually option number 0. on the HST. If you wondered what that was and did not have a far end device, this is where you would select the fed mode by choosing fed mode, and then the pair that you wanted to test, and your duration that you wanted the command state to remain on the line. To abort the command, you would hit the wake up button, as I said previously. So a little bit more functionality available here, but much more manual. Sort of like the difference between our manual mode TDR and the auto ID TDR. So I find the middle one there, the integrated under the actions tab, probably to be the smoothest and a good place to start as you learn the device. So we're going to give you a simple use case scenario here. Let's say that you're dispatched on a case of trouble, and you go to the customer's house as per your M&P. You hook up the UFED. Now you can hook up at the side of the house. You could hook up at the serving terminal. But what you'd want to do is connect your blue leads to the pair, the field pair coming to you, and attach your ground lead. 2 quick presses of the power button or red button automatically turns on the locate toner. So power button twice in a row, the locate toner is automatically turned on. You then have tone on your pair. You go back to the cross box, find the pair, tone is on it, attach the HST, and begin to speak to the far end device. You identify the problem and repair. It's pretty simple as that actually. So we will now take a quick look at a live demonstration using HST on a simulator I have here to give you a little bit better feel of what's going on. So I'll be right back. Alrighty, we're back here. I'm going to give you a live demo here. Hopefully live demos go smoothly. But I'm also I'm simulating kind of a regular POTS case of trouble because again the thought behind the UFED is to be able to use it for anything. So let's say we've got the far end device attached somewhere along the loop or maybe even at the cross box. We've alerted the customer, they know that we're working on the line. We select our digital volt ohm meter and we see that there is a DC battery on the line. Right? Well, we know we want to drop that DC battery, or in other words, disconnect the F1 pair. So if we want actions and fed open all, so number 6, see where that selection is, you'll be brought to a pop-up will come up asking you, what's the duration? How long do you want me to stay open all? Well, I'll just leave it at 60 seconds. Press OK. The HST searches for the far end device, wakes it up, and gives it the command. Once the far end device has acknowledged the command state, you'll see a little timer appear on the screen, and the battery is dropped. All right. Now, as you move through different functions, that timer will kind of follow you along. So in some screens it's not available, other screens it is. But here I'm on my resistance screen, right? You saw that my battery was dropped. I've got a live countdown there. Well, I have no shorts, I have no ground, I have no cross battery. I want to check it for length. I sort of like the TDR. So I'll bounce over here to number 4. I'll start my TDR. Well, that sort of looks like the end of the loop, but just to be sure, I am going to go to the Actions tab, select 8 Fed commands, and institute the TDR helper for 60 seconds. Now, in doing so, I've aborted the previous command, right? And I've given it a new command. So I've shut it off and turned a new command state on. As previously, once the Fed acknowledges, the timer pops up. I hit Start TDR. And for those of you familiar with our manual mode TDR, what TDR helper does is oscillate between a wide open and a dead short. This is particularly handy graphically if you also turn on peak mode, that being the mode that never erases, if you remember from training classes. So you get a ghost image of both the short and the open. Well, it's a pretty definitive way of determining where the end of the loop is, right? And this is just one quick example of how to use the device underneath the Actions tab. I will switch back to my PowerPoint and wrap things up here. So in summary, let's end with frequently asked questions or thoughts that we want to make sure that are reinforced about using the Far End device. So where should I place the UFED on the circuit? Well, always follow your company practice, obviously. And I believe in most cases that is to place the unit at the customer's location, at least to begin testing and to notify the customer that you're there. But really, you can place it anywhere. The most logical points would be demarcation spots, right? Crossbox customer's location. Do I have to use it with a script? Well, no. That's why we wanted this common use case scenario to be pointed out. As I said earlier, I think a lot of technicians are under the impression, well, yeah, that's just for UVerse. It's nothing else. We talked about the 3 ways to interface, and we actually give you a quick demonstration of the one that I think you'll like the best, or at least starting out, and that being the one under the Actions tab, integrated into the tests. So I can turn dial tone or DSL on and off if I have the yellow test leads connected. Well, yes. An off through command passes whatever's hooked to the yellow leads straight through to the blue side. So if that was dial tone, if it was ADSL or even UVerse, an off through command will say, hey, give me the DSL or dial tone back from the field. Can I hook up both pairs of a bonded service in the through mode and then sync up? Well, at this time, no. There is only one set of yellow leads. So single line POTS or single line XDSL only at the present time. Will having the UFED B hooked up invalidate my sync stats? Well, in my opinion, the UFED 2B is virtually invisible to ADSL2 circuits. I can see if I do back-to-back syncs between VDSL circuits, I can see very small differences with and without the UFED. But my answer would be, unless you're right on the very edge of passing or failing, I don't think you will know that the unit is there, to tell you the truth. We spoke about the timer. We got a lot of feedback. This just reiterates that yes, this command states can be aborted either by choosing a new command state from under the Actions tab or from the manual menu. It makes the operation much quicker and smoother, in my opinion. So even if I'm not using the yellow or red leads, they cannot be touching or shorted together? Yes, I really want to emphasize that is correct. Remember, off through in that command mode, the yellow leads are pass through. If they are shorted, you pass through a shorted circuit. If the reds are shorted, they disrupt the sensitive communication circuit between the HST and the UFED 2B. Now I emphasize the sensitive communication circuit because when you think about it, the darn thing has to signal when the cable pair is faulted. And I think you'll be pleasantly surprised at just how hard of a fault can be between the UFED and the HST and still have the device signal or recognize one another. So with that, that's our wrap up to the introductory video. I certainly hope it was worth your time. And I strongly encourage you to give the thing a go. I think once you get used to it, I think you're going to kind of feel like I do. It becomes a pretty invaluable thing. I would hate to be without it. So any questions or comments, you can contact myself or probably best your local JDSU rep. So thank you very much.